Hi, hello everyone. Welcome back to my channel and you are watching my channel DNA Learning School. I am your Dhananjay sir. So last class we discussed about Ohm's law, ohmic devices, non-ohmic devices, resistance and everything. And in today's concept we will go on with resistance and the factors on which it depends. Okay, so last class I told you about a resistance, right? What is resistance? The opposing force to the flow of electrons. Electrons will not move through very easily. Okay, so you know what happens? The metal will oppose. Okay, it will not let the electron to pass through very easily, so it opposes with some force. So that is called a resistance. Okay, so first of all, on what factors the resistance of the conductor depends on? So very important, children, the factors on which the resistance of a conductor depends on. Okay, so a conductor is there, on what factor resistance depends, on what factor the opposing force depends. Okay, so first of all, the resistance of the conductor is directly proportional to the length of the conductor. R is directly proportional to L. Okay, which means it is directly depends, means 90%, almost it depends on directly. So if the length is more, resistance will be more. If length is less, resistance will be less. That is what the directly proportional meaning. So what is directly proportional meaning? If the length is more, the resistance will also be more. If the length is less, the resistance is less. So it is directly depends. Okay, if the length increases, what happens to the resistance? Resistance also increases. This is the first point. The resistance of the conductor is directly proportional to the length of the conductor. The next point, the resistance of the conductor is inversely proportional to the area of cross section of the conductor. So R is inversely proportional to 1 by area. Okay, so what do you mean by that? See, you can see that it is in the denominator. Okay, that is called inversely proportional. If it is a numerator, that is called directly proportional. Okay, it is inversely proportional, which means as the area increases, the resistance decreases. This is what the meaning of inversely proportional. Okay, as the area decreases, resistance increases, so vice versa. Okay, this is how the factors, the resistance of the conductor depends on its area of cross section. And the last one, resistance is directly proportional to the resistivity of the conductor. R is directly proportional to rho. Okay, this is called rho, children. R-H-O. It is a Greek letter. Okay, the resistance is directly proportional to the resistivity of the conductor. What is resistivity? So I will explain in the next next. Okay, R is directly proportional to rho. Rho means resistivity. So they will ask you this question for 2 marks. If they ask you on what factors, how does the resistance of a conductor depends on, you have to write these 3 points as it is. Please note down these 3 points as it is. The resistance of the conductor is directly proportional to the length of the conductor. Resistance of the conductor is inversely proportional to area of cross section of the conductor. Resistance is directly proportional to resistivity of the conductor. When you combine all together, you have to write R is directly proportional to rho L by A, or R equals rho L by A. This is the expression for resistance. Okay, so now I'll come with an explanation, right? So now I have told you that resistance is directly proportional to the length of the conductor. So see here, I have drawn a circuit diagram like this. Okay, now this circuit is offering some 10 ohm of resistance. Say 10 ohm of resistance. Now what I will do means I have increased the length. Okay, so now I have increased the length. Then what happens to the resistance? Resistance will not remains 10 ohm. Okay, so resistance will be more than that. So more than that means maybe a 15 ohm or a 20 ohm. Okay, as the length increases, what happens to the resistance? Resistance also increases. As the length decreases, what happens to the resistance? Resistance also decreases. This is one of the factor. The next one, okay, say that this resistance is R is equals to 15 ohm. Okay, now I have used like this. Okay, so now what I will do, I will replace the full wire. Okay, this is thin wire. Okay, this is thin wire. Now what I will do, I will replace the everything with the thin wire, thick wire. Okay, so now I have taken a thick wire. Okay, now you can see that I am just replacing this everything with the thick wire. Now what happens to the resistance? So now the wire is thick. So wire is thick. Understood? So when the wire is thick, you know what happens? Electrons will have free path to move around. Okay, so there, you just imagine that you have a narrow street. So you can just go in a very slowly, right? So suppose if you have a broad street, or anywhere, if you have a broad area or a broad road where you can just move here and there and you can reach to the next. So like that, what happens when the wire is thick? When the wire is thick, the electrons can move through very easily in the wire. So now, do you think that the resistance is 15 ohm? Okay, will it be more than 15? No, it will be less than 15. Why? Because resistance is inversely proportional to area. I have made the thick wire so that what happens to its area? Area has increased. So now area has increased means what happens to resistance? Resistance will decrease. Okay, so when you use more thick wire, what happens to the resistance? Resistance will decrease. So instead of 15 ohm, it will come down to 10 ohm or less than 15. Okay, so this is how you have to just note down between length and area of cross section. Okay, now let's come to the resistivity of the conductor. Okay, resistivity of the conductor. What is resistivity? Now, so resistivity of the conductor. I have told you that it is directly proportional to the resistivity of the conductor. Okay, so resistivity of the conductor. So what is resistivity? So it is a character. Okay, resistivity of the conductor, or it is also called as nature of material. Nature of material. Okay, so what is resistivity of the conductor? The characteristic property of the material. The characteristic property of the material. Okay, so what is resistivity of the conductor? If they ask you, the characteristic property of the material is called resistivity. 1 mark question, children. Okay, suppose if they ask you on what factor resistance of a conductor depends on, you have to say 3 things: nature of the material, area of cross section of the conductor, and this one, resistivity of the conductor. So this, if they will ask you for 1 mark, means you have to mention this. And if they ask you for 2 marks, how does the resistance of the conductor depends on, means you have to write now what I have written on the board. Okay, the resistivity of the conductor is directly proportional to the length of the conductor, is directly inversely proportional to the area of cross section of the conductor, and resistivity is directly proportional to resistivity of the conductor. Okay, we discussed about 2 things, length and area. Now we have come to the resistivity of the conductor. Okay, what is resistivity of the conductor? Nature of the material. Okay, suppose you just imagine that, okay, I have used a thick wire. Now the resistance is 10 ohm. Okay, so now imagine that I have used an aluminium wire. You know aluminium, right? Okay, aluminium is a metal. Aluminium is a good conductor. Aluminium. Okay, so now what is resistivity means? This rho, resistivity means characteristic property of the material. Means it is the property of the material only. It depends. So some materials are very good conductors. They will offer a very less resistance compared to copper, compared to aluminium, compared to iron. Okay, that is the nature of its material. Okay, so that is called resistivity. So rho, so you know that rho L by A is equals to R. So rho is equals to RA by L. This is the expression for resistivity. Okay, so rho is equals to this one, rho L by A is equals to R. Rho is equals to this A goes here, RA, this L comes here, RA by L. So this is the expression for resistivity. Okay, now I'm talking about resistivity. Let us talk here. Okay, now I am using which wire? Aluminium wire. Okay, so now instead of aluminium wire, instead of aluminium, what if I use silver? Okay, so now I am changing the wire, entire wire. So I am keeping the same length, same area and all. So now I am changing it to silver. Then do you think that the resistance will be same? No. So resistance will be even less than that. Why it is less than that? Because the characteristic property is that in such a way that it is less than aluminium. Okay, so because it's, see, aluminium, its characteristics is like that, but silver is a very best conductor than aluminium. Okay, so which is the best conductor in all means we can say that silver is the best conductor. So then which one comes? Copper. Copper is the best conductor, then the silver. Next we have aluminium. Aluminium. Okay, so because how? Because that is the characteristics of silver. Okay, but still why we are not using silver? So why we are not using? Because silver is very expensive. Okay, silver is very expensive, so only we are not using silver as a conductor. Okay, did you understand? So now what is the SI unit of resistivity? See, you know, the resistance of R, resistance of SI unit of resistance is ohm, area is what? Meter square, and length is what? Meter. So meter gets cancels. So ohm meter is the SI unit of resistivity. Okay, what is the SI unit of resistivity? Ohm meter. Very important, children. Okay, this you have to note down. See, silver has a resistivity of 1.6 into 10 power minus 8 ohm meter. Okay, as resistance is directly proportional to rho. If rho is less, obviously resistance will be less. Okay, so silver's resistance is 1.6 into 10 power minus 8. Okay, so next we have copper. Copper is 1.62 into 10 power minus 8 ohm meter. Okay, so these values and all need not you have to memorize. So you have to just, they will only give, if they give you any problems and all, they will only give you. Okay, I am just telling you why, what is the characteristics, which one has less. So here aluminium we have 2.63 into 10 power minus 8 ohm meter. So from that we come to know that if you use aluminium, it is not a good conductor compared to copper. But when you compare to copper, silver is the best conductor, but silver is very expensive. Okay, so if you are Ambani, you can use the silver wiring and all, but silver is very expensive, so that we are using copper only in most of our domestic circuits. So next, this is about the resistivity of the conductor. Now we will discuss you have one table that I am showing here. So these are the resistivity of different metals and non-metals. So you need not memorize this. So you have to they will only give you to solve any kind of problems. Okay, so resistivity of some metals are here. Okay, so some alloys have resistivity of 44 into 10 power minus 8 ohm meter. So these are all the 44 to 46 into 10 power minus 8 ohm meter. So generally they have more higher resistivity metals. So when you compare to metals, just now I showed you metals which are the metals? Just now I showed you silver, I showed you, then aluminium I showed you, then copper I showed you. Okay, so but alloys have the ranging of, you know, resistivity from 44 into 10 power minus 8 meter per ohm meter to 46, you know, or 8 into 10 to the power of minus 8 ohm meter. And generally some insulators, you know, they are very poor conductor of electricity, they do not conduct only, they will have up to 10 power some 10 to 17, 10 to 10 power 17, which means 1 followed by so many 10 zeros. Okay, this means 1 followed by 17 zeros. So high, you know, resistivity is very high. So R is equals to rho L by A. Since resistance is very high, so what happens, the resistance will be very high. Okay, and we know that according to Ohm's law, R is equals to V by I. Okay, as the no, and also if you want I from this expression, I goes here and R comes down. I is equals to R by I, sorry, V by I is equals to V by R. This R goes here, I comes here. So as the resistance increases, current flowing in the metal decreases. Okay, from that I can say if R is, if more resistivity means more resistance, if more resistance means less current, less resistivity means less resistance means more current. Okay, so this is how we can say that they are good conductors and bad conductors. What are alloys? Okay, we'll continue with alloys. What is an alloy? A homogeneous mixture of two or more metals or non-metal mixed in a proper proportion is called an alloy. Okay, a homogeneous mixture. What do I mean by homogeneous mixture? A homo means same kind. Okay, same kind of metals. Okay, so it is mixed. Okay, so either we can take a metal or a non-metal, so we are going to mix them thoroughly in the proper ratio, or it is another word for ratio is proportion. Okay, so I have written here two example. Bronze, you have already seen, right? Bronze, you know, Paris Olympics is going to happen in June 26, from June 26, and you can see that third place is given by bronze. Okay, so how does the bronze is made? Okay, they will take copper and tin. Okay, they will heat to up to their melting point. Okay, when they heat up to their melting point, what happens? Okay, what happens? Yes, they will convert into liquid form. Okay, so then they will take copper and tin, they will convert into liquid form, then they will mix it thoroughly. Okay, and afterwards they will keep it for some time. Then what happens? It will regain its solid shape. Okay, this is how the bronze is being made. And also brass and all you have seen, right, in your home. So where and all you have seen in utensils, you know, in utensils, vessels, they are all, we are seeing a brass. So you know, it is made up of a copper plus zinc. Okay, same way. So this is the definition for alloys. So alloys are the homogeneous mixture of two or more metals or non-metals mixed in a proper proportions. So now, why do we use alloys? Okay, so we are using alloys in electrical devices. Okay, so very important, children, they will ask you, why do we use alloys in electrical devices? Because there are two major reasons are there. The first reason is alloys have high resistivity than that of its constituent metals. Okay, alloys have high resistivity than that of constituent metals. So which means I have already told you silver. So silver resistivity is what? 1.6 into 10 power minus 8 ohm meter. Okay, these are all you have the table that I have already shown you. In that table, all resistivity is given. Okay, when you compare, see here, silver is a metal, aluminum is a metal, copper is a metal, silver. So all these metals have very less resistivity. But when you use alloy, so I have already told you alloys will have 44 into 10 power minus 6, 44. So which is more, okay, higher resistivity compared to metals. Okay, so I have already written there, right? Bronze is equals to copper plus tin. Okay, so copper and tin both are metals, they have less resistivity, but when you mix it up and when you make it an alloy, what happens? That alloy have high resistivity. Okay, why do we need high resistivity? Listen children, in tungsten and all, tungsten is an alloy. Okay, so tungsten and all, what happens in some electrical devices, we need some resistivity from the some alloys. We are using tungsten in a bulb. Okay, so why? Because it has high resistivity. So what happens? It regains as much as heat. Okay, I need the high resistivity component to be used in the bulb. So I will make a tungsten as an alloy. Okay, like that. We cannot say that we need zero resistance in all the time. We need it for some times. Okay, this is the first point you want to note down. Next, alloys do not oxidize. So alloys do not oxidize, which means what? Burn. Okay, alloys do not oxidize easily at high temperature. Okay, so whatever the temperature you give, how much ever the temperature, which means that also has a limit, so it can withstand some amount of temperature. Okay, so alloys do not oxidize, do not burn, they will not burn easily at high temperature. Okay, so these are the two main reasons that we have to say that why do we use alloys in the electrical devices. You have to note down children. So all these are all very important as far as the exam point of view, and also it has been repeated so many times in the previous year question papers.